Okay, so the chain rule part 2, it's going to be something called U-substitution. So just write that down. Now, I'm going to show you this example here, and we're going to do using the chain rule, the way you know and that you probably like, and then I'm going to show you U-substitution. Some students are going to be like, U-substitution seems like a lot more work. I don't want to do U-substitution. You want to be able to do U-substitution because when derivatives get more complex, we will not be able to do it without doing U-substitution. So you want to get familiar with it and comfortable with it now. Okay, so looking at this question here, without using U-substitution or not knowing anything about U-substitution, we're going to do the chain rule. So we know that the derivative of y with respect to x according to the chain rule, we'd bring that 2 in front, we'd keep our inner function the same. This would be to the power of 1, and then I take the derivative of the inside, which is 1. Okay, so that's chain rule, nice and easy. Here's how we're going to set it up for U-substitution. So y is equal to x minus 1 squared. So what I'm going to do is I'm going to say, I'm going to take my inner function here, and I'm going to say let u equal x minus 1. Okay, so that's the first thing we're going to do. Now let's rewrite our function, putting a u inside. So y is equal to, take that inner function out, let's put a u there and square it. If I said take the derivative of this function here, what the derivative of this would be, we are taking the derivative of u now. So it'd be du with respect to, do you know what with respect to it would be? With respect to x. So du dx is equal to, so the derivative of this function, everybody agrees would just be 1. Okay. Now we're going to go over here and we're going to take the derivative of this function. So the derivative of this would be dy, because we're taking the derivative of y with respect to, oh, not with respect to x. Do you know what this would be with respect to? Yes, with respect to u. The derivative of this function would be 2u to the power of 1. Then what the overall derivative is, so the overall derivative is dy dx is equal to, what's going to happen is we're going to multiply these two derivatives together. So we're going to multiply du dx, which is going to be a 1, and we're going to multiply that times this derivative, so dy over dx. And what happens when you multiply these two derivatives together is, sorry, this should be dy du. Something will cancel. Du over du will cancel. And what we're left with is we're left with dy over dx, which is what we want, which is the derivative. Okay, so you're like, what did we just do? What I basically showed you is dy over dx is equal to, we're going to multiply the two derivatives together. 1 times 2u, that is equal to 2u. And then how am I going to end this? I'm going to now substitute back in u, we said was x minus 1. So dy over dx is equal to 2. U was x minus 1, which we know is the answer. Okay, so don't worry if you're like, oh my God, what did she just do? We're going to do several of these and it will make sense. Okay, so let's look at this one. Write this guy down. Y is equal to 3 times 5x. We're going to do something very basic. Now, if I said I want you to differentiate this, you would just say, okay, that is really, do you guys agree that's 15x? 3 times 5x is 15x. And what will my answer be? What's the derivative of 15x? 15. So now we're going to get that same answer using this more complex U-substitution. Okay? So do you know what I'm going to let u equal to? Yes. So let u equal 5x. So find what your u is, and my u's generally the inner function, and then rewrite it, taking out that 5x and putting in u for it. So y is equal to 3 times u. I've got two different functions now. You need to take the derivative of each function. So this function here is my u function. We're taking the derivative of u with respect to x. So the derivative of this function would be 5. Then I've got a second function, and we're going to take the derivative of y with respect to u. So it's dy du. And the derivative of 3u is just what? What's the derivative of 3u? 3. Yeah, derivative of 3x is just 3. So derivative of 3u is 3. Then dy over dx, which is my derivative, is you're going to multiply these two together. 5 times 3 is 15. Okay, so let's just do some of these u substitutions. Okay, this one here. Let's actually first find the derivative using the chain rule, and then let's do it using u substitution. So using the chain rule, y prime is equal to, Owen, tell me what it would be using the chain rule. Yep. Yes, and then we'll just clean that up by saying 5 times 3 is 15, 3x minus 4 to the 4. Okay, so let's get that exact same answer. So first thing we need to identify what u is going to be. Emily, what do you think I'll let u be? Yes. Okay, so that's step 1. Identify what u is. Step 2 is rewrite your equation now, substituting in u. So y is equal to, let's take 3x minus 4 out, let's put u in, and it's u to the power 5. You've got two different functions, always for u substitution. You've got to differentiate each. So Abby, tell me what I will write for differentiating u is equal to 3x minus 4. Like d what over d what for this first one. Yep, derivative of u with respect to x is equal to, what is that guy equal to? 3. Then, Julie, tell me what I'm going to do to my next function. Derivative of y with respect to u is equal to, careful, not 15. Yes, this would be 5u to the power 4. Then dy over dx is going to be equal to, if I multiply these two functions together, du over du will cross out, and I'll be left with dy over dx. So it's going to be 3 times 5u to the 4. That is equal to 15u to the 4. And from here, substitute back in u. So from here, it would be 15, 3x minus 4 to the 4, which is exactly what we knew it would be. Okay? So this one we could easily do by just the chain rule, but let's do u substitution. So let's first write this as y is equal to 3x squared minus 2x plus 1, and that's to the power of 1/2. Now I know chain rule, it's going to be 1/2 3x squared minus 2x plus 1 to the negative 1/2 and the derivative of the inside. But let's do u substitution. So I'm going to let u equal. Kayla, what's u going to equal to? Yes, this is actually a really messy one to do chain rule and nice to do u substitution. Then I'm going to have y is equal to u to the 1/2. Okay, so from here, Shewa, take the derivative of my first function. What do you want me to write? first, what would the derivative of this be? 6x minus what, sorry? Minus 2. And then Nick, what do you want me to write for my second function? Yep, but first, what do I write? D what over D what? Equals 1/2. Perfect. Okay, dy dx is going to equal this function times this function. So binomial, I'm going to put in a bracket. 6x minus 2. I'm going to have a 1/2. Are you okay if I just write the 1/2 like this? Because it's going to be times, right? So it's going to be this function times this. And then I've got u to the negative 1/2. That u is going to come down. So I'm going to have in my numerator 6x minus 2 over a 2, u to the 1/2. U is going to come out, and this will go in, and I'm going to write it as a radical. So 6x minus 2. Oh, something will be able to be cleaned up, actually. See if you can see it. 2 square root u is 3x squared minus 2x plus 1. Does anybody see what can actually be cleaned up from here? Yeah, in the numerator, I could factor out a 2, and the 2 over 2 will cancel. So factor out a 2 from here, and what would I be left with? 3x minus 1. So if you factor out a 2, you'll be left with 3x minus 1. And that's the derivative. So it's actually much easier to do this one. Like you could try doing chain rule to this one, and it will be messy. Okay, let's end with this question. Do you know what this question would be? Something that the sub would have taught. So let's think about this. This times this. Product law. Okay, so here's how we're going to do this. What is this first function going to be called? U. And this will be my v. So derivative g prime of t, it is equal to, so let's write this first. I always like doing this for power law. U v prime plus v u prime. This is actually going to be quite a complex one at the end of the day, but let's see if we could figure out what this will be. Okay, g prime of t will be u t squared plus 1 to the power of 3 times v prime, this guy. So Sarah, can you tell me what v prime will be? It's going to be v prime will be a chain law. Yep. And then another what, sorry? And then a 3. Okay. So there's uv prime plus v and then u prime. Sean, can you tell me what u prime will be? So the derivative of this using chain rule. So bring the 3 to the front. So it'd be 3, and then what would it be? Yep. Times, what's the derivative of the inner function? So the derivative of that guy, 2t. Okay. Let's clean all this up. So this first one, g prime of t is equal to 4 times 3 is 12. T squared plus 1 to the 3. 3t minus 2 to the 3. Okay, plus 3 times 2t is 6t. Then I had 3t minus 2 to the 4 and t squared plus 1 squared. Now, where this gets more complex is we could actually factor. And now we're going to be going back to something from pre-calc. So consider this two different terms. Let's draw a line underneath each term. From a 12 and a 6t, what am I going to factor out? A 6. Okay, so I'm just going to put the 6 there. I've got t squared plus 1 to the 3 and t squared plus 1 to the 2. What can I factor out from there? Yes, you can always factor out the lowest power. So I could factor out t squared plus 1 to the 2. T squared plus 1 to the 2. Then I've got 3t minus 2 to the 3, 3t minus 2 to the 4. Emily, which one can I factor out? Yes, 3t minus 2 to the 3. Okay, so g prime of t is equal to, pull out your factors first. So we had a 6. We had a t squared plus 1 squared. And I had a 3t minus 2 to the 3. Then what's left over is 12 divided by 6 is 2. This would cancel. And then what I would have over here, 3 minus 1 would give me 1. But because it's a binomial and I've got a 2 in front, make sure you put that t squared minus 1 in a, sorry, t squared plus 1 in a bracket. So what I'd be left with is t squared plus 1 to the power of 1, but I really don't need that invisible 1. Okay, so just t squared plus 1. Then I've got a plus. 6 over 6 will cancel. I've got a t that I'm going to bring down. This will cancel. And what would I be left with when I do this subtraction? 1 bracket. I'd be left with a 3t minus 2. Okay, so from here, always check how you can clean up this bracket. So this bracket, if I was to distribute in the 2, I'm going to write it above it. I get 2t squared plus 2. Over here, I'd get plus 3t squared minus 2t. Okay, so what I'm left with is g prime of t is equal to 6 t squared plus 1 squared, 3t minus 2 cubed, and then this last bracket, 5t squared minus 2t plus 2. And that would be my answer. Okay. I want you to do question 2. And I want you to do question 6, A and C. So you're getting 3 more questions to do. Number 2. They've already started the U-substitution for you. And then number 6, did I say A and C? I want you to do UV prime for this. So like for number 6, this would be your U function, and this would be your V function. So just rewrite this guy as x squared plus 1 to the 1/2. So u v prime plus v u prime. And same with this guy. For c, I want you to do, this is u and this is v. So like we just did, one similar to c. So u v prime plus v u prime. So try those two and try number 2. I'll put up the answers for number 2, like my solutions.